Okay, guys, I was going to assign this one for homework. I like this problem, but it can be a little bit confusing. There's a number of things here, so I wanted to run through it with you in class instead. So I open up the problem. It's 2014. It's problem number 4. For some reason, the fourth problem tends to get ugly at times. So I see a table here. Time in minutes. There's 2 minutes there, 3 there, 3 there, 4 there. So it's irregular intervals. VA of t, meters per minute, so that's velocity. I see different velocity values. Okay, so train A, and there's A's up here, so this must refer to train A, runs back and forth on an east-west section of railroad track. Train A's velocity, measured in meters per minute, is given by a differential function VA of t. Okay, so that they told me what that is. Okay, time t is measured in minutes. Okay, that's nice because that's what's in the table. Selected values for VA of t are given in the table above. Okay, cool. All right, so what do you want? All right, so part A, find the average acceleration of train A over the interval 2 to 8. Okay, this is a really easy problem. It's so easy, you guys always miss it. I've talked about it quite a bit. So A, so average acceleration, it's delta velocity. Go back to algebra 1. It's delta velocity over delta time. Okay, and guys, they want it between times 2 and 8. So it's the velocity of train A at time 8 minus the velocity of train A at time 2 over 8 minus 2. So it's just at 8, it's a negative 120 minus at 2, it's 100 over 6. That's negative 220 over 6. So guys, it's equal to negative 110 over 3 meters per minute squared. Okay? They give you 1 point for that. It's easy, but it's one that you guys often miss when they're talking about average acceleration, average velocity, average rate of change. I'll talk about it in an upcoming class period, but that's what they're looking for. Okay? Okay, part B. Do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t with t between 5 and 8? So they're looking between here, 5 and 8. Okay? Give a reason for your answer. I'll talk about this in an upcoming episode. But when you see this, support the conclusion that the velocity at some point in time, guys, that's kind of that language error. They're looking for you to support something, and at some point in the interval, you should be thinking those words. They're not always very clear, but it's mean value theorem. Okay, you're going to have to use the mean value theorem. So B, for MVT to be valid, the function has to meet 3 conditions. Must be 1, continuous. How do you spell that? 2, differentiable. Okay? It's got to meet those 2 criteria right off the bat. If it doesn't, we're dead. Okay? So, right here, they tell me it's a differentiable function. The problem states that VA of t is differentiable. Therefore, it is also continuous. So conditions 1 and 2 of the MVT are met. Okay? So those are the first two conditions of the mean value theorem. I'll slide this down, give myself a little bit of room. All right, I am going to run out of paper here. I shouldn't have been so cocky. So the third condition, 1, 2, 3. So VA, so the third condition is the slope of the secant in the interval 5 to 8 must equal the derivative f prime of a. Guys, I'm looking at the problem. I'm doing this. It's not actually the mean value theorem because they're not talking about the slope of the secant. Okay, so guys, it's actually the intermediate value theorem. Okay, because they're talking is the velocity, which that's what the table is of. So is the velocity negative 100 meters per second. So intermediate value theorem means that you're taking a value in between the two endpoints, somewhere in the interval. So it's got the same three conditions. You got to be continuous differentiable, but the third condition is a little bit different. So IVT to be valid must be continuous and differentiable. So this is right. It is continuous and differentiable. So conditions 1 and 2 of the IVT are met. Okay, and then the third condition, it doesn't mean the slope of the secant. It just means that the value of the function has to be between those two values. So so the third thing is VA of 8 equals negative 120, which is less than negative 100. I'm trying to prove the negative 100, which is less than 40, which is VA of 5. Therefore, since negative 100 is between VA 5 and VA 8, the IVT guarantees this. Okay, so that's what they're looking for. That's 2 points. 1 point to mention the IVT, 1 point to show that it's in between. So it's close to the mean value theorem. Usually they're going to ask about the mean value theorem, and that's going to be asking for the slope of the secant, but I wasn't reading carefully. And they were looking for velocity, which it's velocity is what they give us. So it just had to show it's an intermediate value. So I will show the next 2 parts in the next video.